Since childhood, I've been curious about how electronic devices work. In this series, I'll demonstrate a fascinating concept for all the curious minds out there. In this video, I'll show you how to create a decentralized sensor that can interface with any Linux kernel device even if it doesn't have any GPIO pins. The concept involves connecting an ultrasonic distance sensor to a Wi-Fi chip, in this case a ESP32 chip, and then writing a code to process the sensor data and transmit it over a UDP port. First, we set up the ESP32 with the Wi-Fi router's SSID and password using the Arduino SDK. Select the appropriate COM port for the ESP32 chipset and upload the code into the device. For this demonstration, I am using a Linux laptop. With UDP transmission happening on the transmitter end, we run a UDP reception code on the Linux laptop. The code is simple and easy to understand, and I'll explain it in a future video. You can find all the codes, circuit diagrams, and the component list in the Git page whose link is present in the description of this video. Now for the demo. We power on the ESP device connected to the ultrasonic sensor. The internal LED on the ESP32 chipset connected to a GPIO on the development board indicates transmission. Once we see the LED blinking, we know transmission on the network has started. We can then run a compiled binary on our Linux laptop. As you can see, the data is being received. When I move an obstacle in front of the sensor, the value changes accordingly. While this project itself is simple, it's a great way to wirelessly receive data within a network. In future videos, I'll explain the different applications of this concept, but for now, I encourage you to imagine your own application and share them in the comment section below. Additionally, remember that we can process the data on any device running a Linux kernel, including smartphones. I've installed an app called Termux on my Android smartphone, turning it into a terminal for compilation. You can find a short video tutorial in the description. By running the compiled binary, you can receive the same ultrasonic distance data on your Android phone. That's it for this video. I'll be back with more in the future, and you can find all the necessary details in the descriptions below. One last thing to note, this project operates within the network and isn't connected to the internet. But that's a topic for another day, and we will get there eventually with much more enhancements. This series will be focused only on the ideas. Enhancements will come later. Thanks for watching, and until next time, goodbye.